Hi, I'm Sean. I'm from Electrical and Electronics Engineering from second year. I'm here to explain about installation of electrical motors. Do not mix the requirements of hazardous local areas. When the motors are installed, when the electrical motors are installed, then the requirements of other hazardous local areas uh, we cannot mix with it, so that they are preserved and they are protected and they can work properly in that area without any disturbance and without any disturbance there. So let's go into this. So, installation and operation of motors. There are many large oil and gas companies with installations around the world that follow national or international standards along with local country requirements. The country that do not have any specific local requirements may choose to adopt the requirements when a system is developed to control a specific area or location, such as the installation of hazardous locations, which typically develops three subgroups here. So, when a electrical motor is installed in any specific area where it is a hazard, where the location is hazardous, so here they are the location, it typically develops into three subgroups. They are, so one, here the regulations generally cover the legal requirements of a system. These regulations are the governing binding laws. The regulation may or may not call for the use of codes or standards. Examples of such regulators are the European directives and the US Code of Federal Regulations. The selection and installation codes include the required mandatory engineering practices. This may cover mandatory codes and standards such as CSA, underwriters, laboratories, UL, EN, IEC, etc. So here in first one we can see that here the regulation generally covers the legal requirements of a system or the governing binding laws. Examples such regulations are the European directives and the US Code of Federal Regulations. Here, third one, the equipment standards are the sound industrial practices, and they can be either mandatory or voluntary. So the equipment are the sound industrial practice. They are the industrial. They are for the industrial practices, and it can be either mandatory or voluntary. So your system, we can see the picture in it. We can see the picture in it. Here, system regulations, selection and installation codes, equipment standards, equipment standards. So, a flow that is a flow chart of a system developing three subgroups. We can see it. Here, the system is divided into three subgroups. They are regulations, selection and installation codes, equipment standards. The hazardous areas. There are three globally accepted groupings of hazardous areas, which are identified differently in both systems. The hazardous area of underground mines is susceptible to fire damp is defined as Group 1 in the IEC based system, but the same area is handled separately by federal regulations enforced under the Mining Safety and Health Administration (MSHA). Here, motors used for the oil and gas industries are generally for explosive gas atmospheres only. Each system also classifies the explosive gas atmosphere into here three globally accepted groupings of hazardous areas, identified differently in both systems. Underground mines, susceptible fire damp, underground mines, fire damp, federal regulations enforced under the Mining Safety and Health Administration. Motors used for they are used for the oil and gas industries mostly, maximum use it. maximum in the maximum oil and gas industries are gonna are are using motors. Here we can see in table 1 there are 3 mine susceptible to fire damp, explosive gases or vapors, combustible combustible dust, ignitable fibers or flyings. Here IEC systems North America. So mines susceptible to fire damp, group 1 MSHA, NRC can, explosive gases or vapors, group 2 class 1, combustible dust, group 3B and 3C, class 2, group 3A, class 3. Here table 2. In table 2, risk of release, the type of the releases IEC based system North American, continuous, zone 0, division 1, intermittent, zone 1, division 1, abnormal, zone 2, division 2. In table 3, we can see that equipment protection level. Here definition, very high level of protection, high level of protection, enhanced level of protection. So here IEC EPL EU attacks category, typical zone of application. So very high level of protection, GA 1 0. So high level of protection, GB 2 1. Here enhanced level of protection, GC 3 2. Yes, here the EC based system identifies an equipment protection level EPL for all the types of protection used in a hazardous area to designate the risk of equipment becoming a source of ignition. The selection and installation codes then specify EPL can be used in which zone. The European systems uses the term category in lieu of EPL, and North American system directly specifies which type of protection can be used in which zone or division. Here in this picture we can see that IEC based system are classified into 6 types. Here country specific regulations attacks Europe 94 by 9 by EC, IEC standards IEC 60079 to 0, harmonized standard EN 60079 to 0, certification by IECEX, certification by ATEX ANV. It is very confusing when one mixes the requirements or definitions of hazardous areas, since the systems vary to a degree in terms of design, third-party certification, requirements, marking, etc. This article will compare the systems and highlight the key differences between them to avoid confusion and when selecting one versus the other for the installation of electrical motors. So here we can see that when one mixes the requirements or definitions of hazardous areas, the system vary to a degree in terms of design, third-party certification requirements, highlight the key differences, compare the systems to avoid confusion. So one versus the other for the installation of electrical motors. So we can see that we have learned about the installation of AC electrical motors in hazard, uh, where it should not the hazardous locations are not should not mixed by the IEC based systems, and LEO, EPL. These based systems are told us to avoid confusion about it. We have key differences about this and the water and the hazardous locations we have to identify it. We have learned about so much about this. Thank you so much.